Hello. Today we're going to talk about Topic 3, Section 1, three-dimensional space. Okay, so we've done two-dimensional. That's like your piece of paper with the x and the y-axis. So here, we've got our x and our y-axis. Now, it's kind of a little different than what you're used to. X is the positive direction this way. So that means if we continue it this way, that's the negative x direction. All right. Our y is positive in this direction. So if we continue it here, okay, this would be our negative y. So we have our first quadrant here, our second, our third, and our, where am I drawing that? And then the fourth. Okay, so it's a little bit backwards, okay, but we just like, as humans, to view the positive things, right? So x and y is positive right here. Then we introduce this z-axis. This is the height, okay? So think of your x and your y as like roads, and your z as your buildings, okay? So how high? Now, here we've got our point now has three numbers, and we are always going to write it in the format of x, y, z. Yep, wouldn't you know? X, y like normal, and z is the last part, would be your height. Okay? And, all right, let's just start with some examples. So here, we want to write down the letters with coordinates 0, 0, 0. So here, 0x, 0y, 0z. So, where everything meets, that would be point F. All right, 2, 0, 0. So y and z, we don't move along those axes, but the x-axis, we move around 2. So the x-axis, we move 2, and there we get to A. All right, I don't know why I'm drawing that like that. Okay, answer it underneath, right? I don't know. Anyway, so then B, write down the coordinates of each of the vertices of the cuboid. So we have E is moving along the y-axis. We didn't move x or z. Okay, so this would just be 0, 1, 0, right? The y moved 1. For B, we moved along the x 2, and we moved along the y 1. So that would be 2, 1, 0. All right, so now let's go up here to G. G only moved along the z-axis. See how it's on that? It's not moved x or y. So that would be 0, 0, 3. H, we moved a y direction as well. So here, x doesn't move, but y is 2, and z is 3. D, we moved along x, but not along y. So that would be 2, 0, 3. And C was moving around all of them. So point C, well, here, I'll just draw it like that. So point C would be 2, 2. Oh, wait, that's not a 2, that's a 1. 1, 3. I messed this one up over here, didn't I? Oopsies. All right, so that should be 0, nope. And I erased the wrong one. Silly me. 0, 1, 3. Okay, so I did that with the blue marker. All right, next one. So let's talk about the midpoint. So if M is the midpoint of AB, then AM is the same distance as MB. Okay, so we have the endpoints of A and B are right here. The midpoint, same way if it was X and a Y. All right, so we take the average. All right, we want to find the middle of the road. That's average. So for the X, we do 1 plus 2 over 2. For Y, we would do -1 plus -2 over 2. And for Z, we would do 2 plus 3 over 2. So this would get us 1 plus 2 is 3, 3 over 2. negative 3 over 2, and 5 over 2. All right, there we go. So here, we want to do, we've got a parallelogram. I'm going to go ahead and label things because that just makes my life easier. So here we're going to have 2, 0, 0. B is going to be 0, 0, 2. And M is 0, 2, 0. Okay, so notice I didn't actually graph this on a three-dimensional plane, but I just visualized the parallelogram, and I just know that M is the midpoint. So if I want to find C, then I know that this jump has to be equal to this jump. So look at your x's. Your x went, so we're going to look at all of them, x, y, and z. X went down 2, y went up 2, and z had no change. So we do that same jump again. We subtract 2, add 2, no change. So C should be negative 2, 4, 0. Okay, because it's halfway. All right, let's do that again. But this time we'll do it to find D. Okay, so we want to find X, Y, and Z of D. So here we know, okay, ooh, it's a little hard to see. So we know the first jump was X had no change, so adding 0. We went from 0 to 2, so we went up 2. And then we went from 2 to 0, so we went down 2. So do that same change again, right? Add 0, add 2, subtract 2. So here's my numbers. So 0, add nothing. 2, add 2. 0, subtract 2. There we have it. Okay, so those are the coordinates of the other vertices. Here we have C, and here we have D. Okay, so now let's do the distance formula. Hopefully you remember this with just 2 points, but now we're in 3D space, so now we've got to add Z. Aw, man, it didn't get it all. Hold on. Silly me. Okay, there we go. Not as cool as I wanted, but hey, whatever. All right, so now we just add the third component. Okay, so the distance formula is the same, pretty much. Okay, so find the distance, the exact distance between A and B. So let's start with that one. So AB. Of course, we could do, I could derive the formula, guys. This is how you would visualize it. You would kind of create a cube, so you'd find this distance, and then there, okay? But we don't need to derive it. We can just use our formula, okay? So take our x's and find the difference. So I'm going to go from A to B. So my A is my second point, x2, y2, and z2, and B is my first point, x1, y1, z1, just because it's easier for me to do left to right. Keep it the same. So we have negative 1 minus negative 1 squared plus our y's, 2 minus negative 2 squared, plus our z's, 3 minus 4 squared. So we get negative 1. All right, so this becomes plus 1. So we get 0 squared. Sorry, keep this going. 0 squared. Here, this is 2 plus 2. So we get 4. 4 squared plus negative 1 squared. Keep going. 0 plus 16 plus 1. We get the square root of 17. So AB, the distance of AB, is the square root of 17. That's the exact answer. So if I want exact, I would say square root of 17. Now, if I say round, okay, to 3 sig figs, then I would put it in my calculator, and we would represent that more with 2 squiggly lines, right? That means rounded, roughly, about. So you would write, let's see, we would have 4.1231056, right, in our calculator. So here, 3 sig figs would be 4.12. Okay, that would be your about answer. So, some vocab you want to know. Okay, here we have a pyramid. All right, you've seen these before, hopefully in pictures when they talk about Egypt and Sphinx and all that good stuff. So we want to label certain parts. The apex is the point, okay, the top of it, all right, where it all comes to. Okay, so apex would be, in this case, point E. A lateral face, okay, a lateral would be your sides, so it's the triangles in this side. Okay, so on this in this pyramid, it would be triangle EAB, triangle ECB, triangle EDC, triangle EAD. Okay, the center of the base, okay, of course our base would be this square. Okay, it doesn't always have to be a square or a rectangle. That's not really a square looking, but yeah, it can vary. But the center of the base is at G. Notice it goes through our apex. Okay, to be a right pyramid, it would go through our apex. Okay, so your center is where the diagonals are. Okay, doesn't always go through the apex. All right, it's where the diagonals always meet. All right, the right pyramid, this is what I was talking about earlier, I jumped ahead, sorry. All right, is when it goes through the apex. So when that does happen, it's a right pyramid, not all the time. All right, a tetrahedron, you'll hear that word a lot. A tetrahedron is this shape right here. Okay, the base has 3 sides. The base is a triangle. Okay, so this is a tetrahedron. All right, and the slant height would be the height of your lateral face. So the height of that triangle. Okay, so the height of BCE. Okay, so it's kind of like what the leaning side is, right? You just want to know when I say these words what they mean. Okay, so let's do some examples. So here we have a pyramid. It is square-based, as shown below, and the length of the side of the square is 12, and the perpendicular height of the pyramid is 8. Okay, so perpendicular height is 8, and notice it's going through the apex. So find the surface area of the pyramid. Well, we've got the base is one part of the pyramid, right? If we were able to hold this pyramid, that would be one face. So the base is one thing we need to find. So our base is just 12 times 12, so 144. And now we need to get the 4 triangles. Those are the other parts of the pyramid. So if you were holding it, you could also touch the 4 sides. Well, we need to get those. So let's visualize. All right, I'm going to use E, B, and C. So if we think about this triangle, it helps if we knew the height of it, right? That's how we find the area of a triangle, base times height. Well, we know that since all the triangles are the same, right, because a square, right, that this is going to be an isosceles. And so this is cutting this in half. So this is 6. So here we've got a triangle, all right, where these are 6. All right, now, I still need to find out what this is, and that's our lateral height, right, our slant height. So I'm going to call that L. Okay, because I don't want to use S because it looks like 2s and 5s. What am I saying? It looks like 5s. So I'm going to draw another triangle. I know, because why not? So I'm going to do it right here. So I've taken my square and I've kind of cut it in half right here. So that distance is 6, right? Think about it. We're cutting it in half, both directions. So here now we've got a triangle, right? Because this goes through the apex. So it's a perpendicular height, so we know that's a right angle. So here we've got our triangle. So now we can figure out what L is, because 8 squared plus 6 squared equals L squared, the slant height squared. Right? Pythagorean theorem. So 64 plus 36. So we get 100. And the only thing that makes sense here would be 10, because we're talking about positive height. So now we know that this is 10. So the slant height is 10. So now we can find the area of a triangle. So we go back over here. So the area of a triangle is 1/2 base times height. So the base is 12 and the height is 10. So we get 60. And since we have 4 of them, okay, that's going to be 4 times 60. So that is 240. So our total, use a different color, why not? Okay, our total is going to be 144 plus 240. So we get 384. Okay, well, centimeters squared, because surface area. All right. Let's keep it going. Example 2. So here is our pyramid. The volume of any shape is always base times height, right? The perpendicular height. So, but when you have pyramids or cones or anything that comes to a point, okay, so you don't have 2 bases anymore, you have it coming to a point, you just do 1/3 base times height. And this is area of the base. Okay. So here we've got the same pyramid as before, but now we want to find the volume. So the area of the base, is just 12 times 12. So 144. And the height is 8. So we literally just do 1/3 times 144 times 8. So we do that on our calculator. Hold on. You get 384. 384, and since it is volume, it's cubic centimeters. Okay. Lengths are just 1 centimeter. Area is centimeters squared, and volume is centimeters cubed. All right. Cones. Okay, so here we want to find the surface area of a piping nozzle. All right, correct to 3 sig figs. So, okay, so your formula sheet doesn't give you all of the breakdowns of every surface area and volume of everything, but they do give you certain parts. They do tell you that the surface area of the curved portion is pi RL. Okay, so pi RL is the curved portion. It doesn't include the circle, so you need to decide whether or not that's included in the surface area that you're looking for. Okay, surface area would include it, but sometimes they ask just for the lateral area. Okay, so here we've got a piping nozzle. So we've got the radius of the base is 15 centimeters. So I'm going to go ahead and use this one up here. So the radius is 15. And the radius of the top is 3. So think of it, they took this cone and they cut this part off right? And so that way the icing could flow through. Okay, and so that radius is 3. Okay, so you have a smaller cone on top of a larger cone. Okay, the perpendicular height of the large cone is 36, so the whole height is going to be 36. And the height of the cone that is removed from the top is 7.2. So the part that's removed is only 7.2. So find the surface area of the piping nozzle. So really we've got this whole cone minus the little cone. Okay, so our piping nozzle, I'm going to write it out for you. In this case is the big cone minus small cone. Okay, that looks like core. I guess I should fix it. Okay. Well, I don't want somebody else to read this later and go, what was she saying? Okay, so let's find the big cone. Okay, so for the big cone, we need to do pi times r times L. So we do pi times r, which is 15, the radius, times L. Well, L is the slant height. Well, look what we have. We have a triangle. So get your slant height by doing 15 squared plus 36 squared and then taking the square root. Okay, we do that, we get 39 squared. So the slant height is 39. So now we do 15 times 39 times pi. Okay, I'm going to write it all out because I want to be exact until the very end. So 15 times 39 is 585 pi. And now let's do the small cone. So pi r L. So pi times the radius, which is 3, and the height. Okay, so we need to figure out what that slant height is. That's something different. That's going to be 7.2 squared plus 3 squared, and then take the square root. We should get 7.8 squared. So the slant height is 7.8. That's a decimal. Okay, so 3 times 7.8 is 23.4 pi. And so now our nozzle is 585 pi minus 23.4 pi. So in the exact sense, it is, let me do that, 561.6 pi. So this is the exact answer, but it asked for it correct to 3 sig figs. So go ahead and plug that into your calculator, and you should get the surface area is 1764.318 ... Okay, well, it said to 3 significant figures, so 176, that's the one we round to. So our surface area is 1760. Yeah, so 1760 centimeters squared. That's what they wanted. Okay, so make sure you do your rounding correctly. Okay, so now we want to find the volume of a cone. Okay, so instead of finding the surface area, let's find just the volume of a simple cone. All right, we do the same thing as before. This one has an apex. It comes to a point. So we have 1/3 base times height. Okay, well, this is a cone, so the base is going to be a circle. So the base is now pi r squared. So that's your formula. Okay, it's not that hard to remember, in my opinion, but I think it is still in their formula sheet. Okay, so in case you freak out, it is there. Okay, so So let's do that. We want to find the exact volume. So no rounding. Volume is 1/3 the base. Well, the base is a radius of 3, so pi r squared. And the height is 7. So we have 1/3 times pi times 9 times 7. We work that out. It is 21 pi. That's your exact answer. All right, next one. So let's find the surface area of a sphere. All right, this one I don't really have anything fancy to remember it, unless you know some calculus, which these are derivatives and integrals of each other. Okay, so notice the derivative of the volume is the surface area. Integral of that is that. Anyway, again, you don't have to know that, but that's how I remember it. So here, we can always, again, look in our formula books for that, formula sheets. So here, find the surface area of a sphere. So the surface area is 4 times pi times your radius, 3.4 squared. And we're going to round to the nearest centimeter squared. So we do this on our calculator. 4 times pi times 3.4 squared, and we should get 154. What am I saying? 145. 145.267 ... right? Round to the nearest centimeter, we get 145 centimeters. The next one, find the volume. So that's 4/3 times pi times 3.4 cubed. So very similar to before. Okay, so now we get 493.908 ... and to the nearest centimeter would be 494 cubic centimeters. There you go, just knowing your formulas. Okay, so for this problem, we've got an ice cream cone. All right, think of it as a hemisphere on top of a cone. Okay, that's what a hemisphere is. It's half of a sphere. So hemi means half. Okay, so the radius is 4 centimeters, and we know, let's see, the height, all right, the cone height, more specifically, is 8. So we want to find out the volume and the surface area of the model. Okay, so let's start with the volume. So the volume of a sphere, okay, is 4/3 pi r cubed, but we only want half of the sphere, so we want whatever half of the sphere is, all right, plus my cone, and my cone is just 1/3 area of the base times the height. So let's plug in what we know. So we have 1/2 times 4/3 times pi. My radius of my sphere is 4, so 4 cubed. That's all being multiplied. Plus 1/3 times the area of the base. The base is a circle, so pi r squared. So pi 4 squared times the height, which is 8. All right, we plug all that into our calculator, and that was exact. This is roughly 268.082 ... Okay, so we want it to 3 significant figures, so 268. So around there, we get 268 cubic centimeters. Okay, so now we do our surface area. So our surface area, we need our hemisphere, so that's just half of a sphere. So the surface area of a sphere is 4 pi r squared, and plus our cone, which is pi rl. Plug in what you know. So 1/2, well, I don't know why I put those parentheses there. I'm going to put multiplication signs. 4 times pi times the radius, 4 squared, plus pi times our radius times our slant height. So we have to get our slant height here. So remember, we use our Pythagorean theorem, 8 squared plus 4 squared. So, yeah, well, I guess we could, if we want to be exact, we could just plug in the square root of, was that 64 plus 16? So 80. So the slant height is just the square root of 80. So if we plug all that into our calculator and let it do all the work for us, we should get 212.929 ... round to 3 sig figs would be 213 square centimeters. Okay? So we've done all that stuff before, so that was just kind of a refresher. So hopefully that all came easier. This, we want to find the angle between a line and a plane. So here we've got our cuboid, we've filled in our given information. Okay, so AB is 8, AD is 3, I'm just making sure these are all right, and AI is 5. Well, notice that AI is 5, well, that's the same as LD, KC, JB. Okay, so we want to find the angle between DB and LB. So DB and LB, here we have it illustrated. So to find that angle, it helps to know some more pieces, right? Maybe it might help to know this distance. Well, hopefully we can see that this is a triangle right here. So we can find this one by doing the square root of 3 squared plus 8 squared. Pythagorean theorem, guys. Okay, so that's 9 plus 64. So what is that, 73? So this is the square root of 73. And now to find our angle, hopefully remember some geometry. That whole SOHCAHTOA thing. Okay, so angle B, the tangent of the angle that we want is opposite. So opposite of that angle is 5 over the square root of 73. I know you've done it. You just got to tap in there and remember. Okay, so the tangent of that angle is opposite over adjacent. And to move tangent to the other side, the opposite of tangent is arctangent. Ooh. And that's like, it looks like a little inverse, so -1 right there. So the inverse tangent of 5 over the square root of 73. So this is where you put second tangent. Okay, so some calculators write it as arctangent, some have tangent with a -1. Okay, you plug that into your calculator and you should get approximately 30.336. And then, of course, rounded to 3 sig figs, okay, would be 30.3 degrees. So you want to make sure that you are in the correct mode. So let me show how you can fix that. So on this calculator, you would go to your mode, and here it's on radians. So you want to go down and make sure the degrees is selected. So hit enter. And then now I should be able to do second tangent and then 5 divided by the square root of 73. And there we have it. Okay, so let's do another one. We want to calculate the angle between line segments FA and AE. So FA and AE. So this is this angle right here. I'm going to call that theta. So, well, we know some distances, like we know this distance is the same as CD, so that's just 6. And we know this one, well, we can get this triangle. Let me change my color up. So if we look at this triangle, that's 8, this is 4, same height. So we can use Pythagorean theorem here. So 8 squared plus 4 squared equals AE squared. So that's 64 plus 16, we just did this, or something similar, is AE. So this is the square root of 80. So now we have our angle. And since these are on the side of our cuboid, right, this one, AF is floating in space, I'm going to leave that one alone, right? It's much easier to find the ones that are on the surface. Okay, and that angle is going to be a right angle when it's on the surface. Okay, so here we can do tangent of our theta is 6 over the square root of 80. So the exact answer would be the arctangent of 6 over the square root of 80. Of course, you'd simplify that if you had to. And then you plug that into your calculator, and what do we get? Ooh, sorry, stray mark. We get 33.854 ... degrees. We want to round 33.9 degrees. There you have it. Okay, so now, again, identifying your right angle is going to be useful. So let's say we wanted to find the angle between GN and this bottom area. Okay, so I need to make a triangle. There's a couple different ways I could approach it. Yes, there's multiple triangles you can do. I'm just going to do the same one that Cognity drew. So they drew a line from B to N, and they made this triangle. Okay, so here we have this triangle we're trying to make, with this angle being theta. Okay, so a couple things we want to notice. We need to know that N is the midpoint. That's useful because this distance right here is 4. And we should know that AB is the same as CD, so that's 6. So we can easily calculate BN with the Pythagorean theorem. And what is that? Because again, this is a right angle, so 36 plus 16 is 52. So the square root of 52 is this one. And we know this this distance is 4. So now we've got two sides of our triangle, and see how GN is the one again floating in space. That one I didn't find. So this part is my right angle over here. So the tangent, the angle I'm looking for, is going to be opposite over adjacent. So the exact answer is arctangent 4 over the square root of 52. And let's see, we roughly get 29.017 degrees, so we round and get 29.0. That doesn't, yeah, that seems weird to me, but yeah, that's how it would be. 3 significant figures. Okay. So here's some more practice with finding the angles. I figured I would do more examples, try them, see if you can do them on your own. So for here, angle EMG, so EMG, this would be this angle is theta. We know the height is 6, and since G is the midpoint, okay, right? M is the midpoint, G is in that diagonal. We know that this part has to be 5. So we know the tangent of theta is 6 over 5. So theta is the inverse tangent of 6 over 5. And rounded to 3 sig figs is 50.2 degrees. Okay, so for part B, okay, we're going to find angle ECM. So angle CEM is right here. So this is the angle. So try to envision It's on the face, the lateral face of my pyramid. So here we know this distance is 5, and we want to find that slant height. So think about what we had here. We had 6 and 5, so we use the Pythagorean theorem, and this should get us the square root of 36 plus 25. So that should get us the square root of 61. So this is our right angle. Tangent of that angle is going to be the square root of 61 over 5. So our angle is arctangent of square root of 61 over 5, which is, I believe, 57.4 degrees. Okay? And the last one is angle ECG. So angle ECG is this angle right here. So try to envision this right here. Now here you've also got a rectangle or on your base. Well, it looks like a rectangle, but you know that the whole thing is a square. So that halfway is 5, this halfway is 5. So this is just 5 square roots of 2 right here. Okay. So that is just 5 square roots of 2, or you could say it's the square root of 50, use the Pythagorean theorem. So tangent of the angle should be 6 over the square root of 50. So we do arctangent of 6 over the square root of 50, and we should get 40.3 degrees, rounded to 3 significant figures. Hopefully that makes sense. If not, just ask me in class. I'd be happy to go over it again.